Hi, I'm TJ Glowick and this is my presentation for Project 1. In order for a jet to land on an aircraft carrier, an arresting system is employed. The jet latches onto a cable as it lands and the arresting system decelerates the craft. The jet applies a force to the system, represented by M1 times Y1 double dot. K1 represents the total stiffness of the first cable. K2 is the stiffness of the second cable. Kd is the damping constant such that the jet will safely decelerate. The model was converted to MATLAB code. These arrays can be used as inputs in Simulink, which easily solves the state space model. The damping constant was manipulated by hand until the jet could safely decelerate. This graph represents the displacement of the jet. It just reaches the end of the runway before being pulled back by the spring force in the cables. It settles at about 180 meters. The top graph shows the velocity, which oscillates a bit before settling at 0 meters per second. This was obtained by taking the derivative of displacement. The second graph is acceleration, which peaks at about 10 meters per second. This was obtained by taking the derivative of velocity. Part B uses the same system as Part A because with this setup the damping constant can't be altered. This means that some craft perform better than others. As shown in the graph, the UAV rapidly bounces back and forth. The velocity of the UAV also rapidly oscillates. The acceleration peaks at around 45 meters per second, which may damage the craft. Since the damping constant was designed specifically for a fighter jet, its range of usability is limited to craft of similar size and speed. The jet performs significantly better than the UAV in this system. Part C differs from A and B because the damping is able to be manipulated by using water spinners. The distance between the surfaces of the spinner impacts how fast energy is removed from the system. Otherwise, the setup remains the same. The formula on the right represents the force generated by the spinners. These graphs represent the displacement and acceleration of the jet using the water spinner system. The jet safely stops before reaching the end of the runway and experiences a maximum acceleration of about 10 meters per second. The first graph represents the displacement of the UAV and the second graph represents its acceleration. With the water spinner setup, the UAV only experiences 18 meters per second of acceleration and doesn't oscillate so much. It is a significant improvement over the previous system.